Hi, everyone. So today we're going to talk about the merge. And first, I'm going to tell you about the summary. So we're going to discuss about what the merge is and what are the expectations that you can have about the merge. I'm going to also dive into the architecture of an Ethereum client. And we're going to see what is going to change from an execution layer perspective after the merge. We are also going to discuss modularity, which is going to be a concept that is going to impact everything from the protocol level to the client architecture itself. We're going to talk about how do we test the merge currently and what are the challenges from an engineering standpoint. Obviously, the timeline when merge, and what are the opportunities that we're going to have in the post-merge world. I'm going to speak a little bit about scalability, especially scaling wars, and post-merge opportunities. So first, a little bit about myself. So my name is Sajida Zouarhi. I've been in blockchain, crypto since 2015. I first started working at Consensus as a tech lead on cryptographic projects, and soon after on Tezos on the strategy side and due diligence side. Also worked as a PM of the Hyperledger Besu team for a year and a half approximately, working on a specific Ethereum client. So what is the merge? So it's pretty simple. The idea is that you have this beacon chain that has been launched in 2020 that is going to merge with the current mainnet chain that we all know. And so it's quite simple to understand that, but to do it is more complex. Simply what is going to happen is that nothing is going to change from a mainnet perspective. Every balances, accounts, all of that is going to remain. But the only thing is that from now on, it's the consensus layer that is going to drive the blockchain forward. The three important things that Ethereum is trying to achieve with the merge is decentralization, security, but essentially scalability, which is the part that was missing from the trilemma that is part of Ethereum vision. So the idea, as I told you, is to have the beacon chain that has been running since 2020 become the leader of the consensus on Ethereum. And that means that validating block is not going to be a miner's job, it's going to be a validator's job. And the way that you have security around that is by staking Ethereum. And this has some nice properties. And so specifically, what can we expect from the merge? So first, obviously, energy efficiency is going to be a big topic. This is the biggest drop overnight in terms of network carbon footprint. And so the idea is that people always think that the merge is going to solve some UX issues that we have on Ethereum, especially gas fees, but that's not even going to impact that, or at least not in a drastic way. It's really about making Ethereum more sustainable and scalable. It's also interesting because since we have now approximately 20 billion worth of ETH staked and so locked on the protocol, it creates interesting constraints on the economic side. And so obviously, Ether that is locked is not on the market, and so you can see how that can be interesting from a crypto economics perspective. The good news about the merge is also that you have a seamless developer experience because really there is nothing much to do. Application, dapps are going to be working. There is no big change in terms of APIs and integration. So really for, I guess, users and dApp developers, there is not much that is going to change. It's really the node runner that is impacted because the architecture that you're going to need to run a node on Ethereum from now on is going to be composed of two sides, the consensus client and the execution client. So, as I told you, I was the product manager of Hyperledger Besu for a while, and I'm going to use the architecture of Besu just to walk you through the typical architecture of an Ethereum client. So here are 6 major systems that you can find in most clients. The block production side, the EVM. I'm going to start with the EVM engine. So the idea, of course, in a blockchain is that you're able to execute some bytecode that is compiled from a higher level language, such as Solidity, for example. You also have data storage in the form of Merkle-Patricia trees for state. You have peer-to-peer communication because everyone in the network needs to be able to discuss with other clients and share information, transaction in a peer-to-peer fashion. You have the consensus protocol that is key because these are the predefined rules that all validators are going to follow to validate new block, make sure they're aligned with the protocol, and if that is so, propagate that payload that they just created to other people in the network. JSON RPC communication, of course, it's important because we have on-chain data as a dApp. How do you query information if you don't have endpoints? So that's pretty important. And the last one is block production. I wanted to finish with this one because I think this is the one that is most interesting, related to the merge, but also what is going to happen after the merge. Block production is pretty simple. Every client, every node has a mempool. It's quite unique to yourself because it depends on where you are in the network, what you hear, what you see, what transaction you receive. And so the idea is just to go through that mempool, assemble some transaction, batch them together, create a block, propagate it. And so we're going to see how this is interesting and what opportunities it offers in terms of PBS, so proposer-builder separation in terms of block production, and MEV, for example. Another nice piece of technology is the engine API. Of course, you have two clients that need to interact with each other, so you need specific technology to make that work, and so that's the engine API. What is interesting here is that by analyzing this API, you understand what are the roles that are going to remain on the execution client side. For example, maintaining the state is also going to be on the it1 client. So it1 client is the name that we give to current Ethereum client. And they also have to provide access to the state for new nodes in the network that are looking to sync. They have to prepare and return the payloads to the consensus clients and execute those transactions. And also, quite interestingly, they're also responsible for providing the APIs that dApps wallets are going to be using. So it's not like Ethereum client as we know them today are going to disappear. It's more like they're going to evolve, and there is a separation of concerns that is going to happen, where the consensus side of things is going to be handled by new generation of clients. Maybe you know them, like, for example, Teku and others. And the execution will remain the responsibility of the current Ethereum client. So here is a little bit of a visual comparison of what is happening on the architecture side today and what is going to be post-merge. So you can see here that the mining side of things is very much within the client that is running currently. And post-merge, both of that is going to be, the validation is going to be happen outside of the execution layer client, is going to be on the beacon chain. And what is interesting here is that it's now the beacon chain that is driving the blockchain forward. So a very important topic that I wanted to discuss as well is modularity. Yeah. So I think you see where I'm coming from. We're seeing now that even at the protocol level, we have a separation of concerns. We have a modularization happening in the protocol logic. You can also find that at the client architecture level because, you know, now if we're extracting the consensus side, why not extract also like the transaction pool? The EVM has been extracted, for example, on Bezu. Clients such as Aragon have embraced modularization by design, and already their own modules can be run as independent components. So that's quite interesting. Modularization in the protocol itself, as I said, is going to offer new possibilities because, of course, if you can now separate clearly the roles, you can have new actors coming and saying, okay, we had no previous interest in building software for client, but if now we can just focus on block building, for example, that's an activity that we want to develop. That's maybe a new business model. So that's interesting in terms of opportunities. And the other thing is that modularizing the architecture is very good when you're doing open source software, because if a new contributor wants to come into your code base, having to basically go through the whole code base just to make an impact on some small feature that you want to add has very much friction. But if you have modules, then people can just onboard on that specific domain and, you know, add value to your project quite directly. So it's good to remind ourselves about what is happening currently. This is one of the biggest engineering challenges. It has never been done in history, and we are basically changing a whole protocol while still running an economy on top of it. So I've put some numbers here. You know, this can be a little bit scary, but actually I'm going to walk you through what is being done to test the merge. I also want to point out that I don't think that the merge is important just for Ethereum. I think it's important for the whole Web3 ecosystem, just because of the place that Ethereum has currently, the innovation it carries, the users, the dApps, and somehow also the trust of the people that are currently onboarding on crypto and Web3. So it's important for everyone, not just for maximalists, I guess. So the road to the merge was actually quite long. You know, the merge has been in discussion for several years, but I really noticed an acceleration in the past year, first with Rayonism and then at the Enfora week. So we had in October 2021 a week-long interoperability workshop with all the client teams in Greece. That was very interesting because in the span of 1 week, we achieved more work than maybe in 3 months of async work. So that was really a catalyzer for what came up next. It was also the first time running the proof of work to proof of stake transition. The good thing about interoperability and being focused on that is that you can adapt your testing approach. If you're testing your software as a client maintainer, in your own environment, maybe you're passing those tests, fine. But ultimately, it's of no use, because what you really want is to see how you work with other clients. So what we do is we run combos of different client combinations, and we see if they're interoperable and if they're working seamlessly. If your client is working fine, but then when you start integrating with other clients, you start to have consensus failure, then that means that you're not going to be passing the merge readiness checklist that we have. And so the idea behind testing the merge was to develop a series of tests that are more BDD, so behavior driven development, much more than TDD. And the idea of that is just to make sure that we know what is going to happen when the merge happens, because we don't have a second chance. So when we merge, we need to make sure that the protocol is running as smoothly as it is today. And so that also means using other techniques such as fuzzing. It's just because when you develop a protocol or you develop a client or any piece of software, really, you have your own approach in mind. But you're thinking about how your software should work, not necessarily how some users or other people are going to use it in the wrong way. And so by using fuzzing techniques, you're really trying to explore the whole domain of possibilities that you have. So I personally was very much interested by the testing the merge part of the merge, sorry. Just because we really saw new initiatives coming from the community and people really trying to push further the testing, strategy to make sure that the merge goes smoothly. One thing that was also nice, was the shadow forks. So if you're not familiar with shadow forks, basically the idea is, you take a network that has been running for a long time, like a testnet that is sort of trusted. You take a snapshot of it, so that means that you have the whole historical state up until this point. And then you bootstrap a new testnet with that, and you go through the merge on it. That is nice because it's like this shadow fork that you have share the same DNA as the testnet itself. It's much more interesting, in a sense, to test the merge than, for example, some public testnets that are also available, like Kill, that have other types of purposes. So there's quite some complexity behind testing the merge. That's my point. So when merge, deadlines and timelines in general in the Ethereum ecosystem are a tricky thing. So my advice is not to get too attached to dates. But we know now that the expectation of the foundation, or the estimation, is September 2022. What is much more interesting, actually, is following the steps that are going to lead to the merge. And so, for example, early August, we're going to have some nice things happening on Gurley, the merge specifically, after the activation of the Bellatrix upgrade on Prater, so on the Beacon chain side. And so that's something that you can follow, and basically how this is going to happen is going to be a good indicator of, are we in the right direction to merge, for example, in September, or do we need more testing? So preparing for the post-merge world. So the first thing, and I guess I mentioned that earlier in the presentation, is going to be the scaling wars. It was funny, yesterday I was seeing a tweet from Sasal about this and other people, and I think you felt that also by just being at HCC. There is a lot of discussion about rollups, layer 2s in general, and scalability. So what does it mean? And I'm not going to dive deeper in rollup, but just to give you an idea, we know optimistic rollups, we know ZK rollups. Optimistic rollups are really based on the assumption that, you don't really have to validate or prove the validity of anything. You just commit whatever you have in terms of transaction on the layer 1 and hope for the best. But if anyone that is witnessing this see a malicious action, they can basically generate a fraud proof, and then a dispute happen. The ZK approach is quite different. It's more that you have to prove the validity up front, and then it's being verified, and you can commit valid transaction to the layer 1. There are other layer 2 solutions that I'm not going to talk about, but like state channels, side chains, etc. The interesting thing is that scalability is also being tackled at the layer 1 level, so on-chain. And so basically we have something called sharding that is in the works, and the idea is to split the workload across different shards. So basically you have different chains, shards, and validators can really focus on one shard and not have to reprocess the entirety of the transaction of the blockchain. And so that is going to result in some good improvements in scalability. And what I like the most about that is the compound effect of all of this innovation happening on Ethereum right now. Here you see the current TPS that we have, so transaction per second. With rollups, these are the numbers that we hope to achieve, so 1K to 4K. And if you have rollups technology, for example, combined with sharding on the layer 1, you can achieve much more interesting numbers in terms of performance, as far as 100,000 per estimations. Okay, so post-merge. So I said I wanted to discuss about the post-merge world because that's really the part that I'm really, wondering about. What is going to happen after the merge? And so I'm just going to speak a little bit about the mempool. I'm sorry there are some issues with the slides because they had to be downloaded and then displayed. So this is the mempool, this bunch of Lego bricks. And so what you can do in your mempool, I mentioned that in the block production part earlier, you can order your transaction the way you want. And so you can be pretty naive about that and just build something quite simple, just by freshness of the transaction. Maybe if you're a little bit financially motivated, which you are as a miner, you want to order them in a way that you're going to include the transaction that have the highest fee. And so for those who are unclear about what this means, just think about last time you wanted to mint that NFT really badly, and you had to increase the fees just to make sure that your transaction gets included in the next block. And so that's the type of thing that miners are, attracted to, and they will include your transaction faster. But you can do other stuff. You can be smarter about it and order transaction in a way that helps you leverage some opportunities, like arbitrage, for example, between dexes and different dapps. And that's something that is going to be made even more easy with a post-merge type of architecture, as I mentioned before, with the modularization aspect. Even some people that are currently working on tooling, working around the mempool, working as infra providers, such as Infura or others, they are very well placed to leverage their current position to start developing more sophisticated ways of handling transaction. And so just think about what type of opportunities from an economical standpoint that can offer, and maybe attract even more innovation and just business on Ethereum. So the question that I hear often is all of this new innovation, the rollups, MEV, all of this stuff happening on Ethereum, is it a threat to Ethereum as a layer 1? People are now going to onboard directly on rollup. They might not even interact with Ethereum as a layer 1. Is that a bad thing? I think quite the opposite. It's a very good thing, because ultimately they all pay fees. And so what that means is that the more layers you have on top of Ethereum that are leveraging layer 1 for security guarantees, like anchoring some information, some transaction, the more fees are going to, and value is going to trickle down to the layer 1. And so the layer 1 is going to be more as a premium settlement layer, and everything that you want to do that is more UX-oriented, for example, you want to pass an EIP currently on Ethereum that is going to maybe improve the user experience. It's very hard. Like, you have to discuss with the core devs, you have to make sure your EIP is going to be included in the next upgrade. This might happen in 6 months. A lot of EIPs have been delayed because of the merge. I'm not sure people know that, but there's a lot of innovation that is already sort of ready on Ethereum that is being delayed because of the merge, and that's because you cannot disrupt a protocol as easily, especially Ethereum. But on the rollup side, you don't have to go through that type of process, and so you can be much more agile, and that means more opportunities and more, flexibility on Ethereum, and that can make Ethereum and Ethereum ecosystem as a whole competitive compared to other layer 1s that we see today. So I'm going to leave you with this, I guess, picture that I really like. Ethereum roadmap is very rich. There is a lot of room for growth and room for newcomers. I think it's interesting to see that Ethereum is always evolving. The merge is not a fix. The merge is not something that we're doing to patch issues with Ethereum scalability. The merge is the next evolution of Ethereum. And so this evolution is actually comprised of a lot of steps. And so after the merge, we have the surge, the verge, the purge, the splurge. I really love saying that. And so this is what is going to happen. And so this, I think, paints a very bright and hopeful picture for Ethereum and is a good way to attract new talent and to say to people, the landscape as we know it today is going to change a lot after the merge. And the time is now if you want to leverage that and maybe start working with the community. So that's a wrap. That's it for me. And thank you. If you have any questions, feel free to ask them down. Thanks.
Thank you. It's something you already mentioned, but I still have some questions about like the mempool management and flashbots, because right now miners are still big entities. We want to see Ethereum as decentralized, but it's
I don't understand what you're saying.
Sorry, is that better?
No, can you?
Okay, I'm saying that the miners are more centralized than we would want to, and this means that we have private mempools with flashbots and everything. And after the merge, hopefully the validation will be more decentralized, but still you say we can be very creative about the mempool and how it's processed. So do you expect things like flashbots to continue to exist after the merge?
Yeah, that's a very good question. I think flashbots were very early on something that is going to be fundamental and develop into a whole industry on top of Ethereum, MEV. I think you hear a lot of projects saying that we had to start in a centralized fashion, but it's in our roadmap to become decentralized, etc. The good thing that I understood, at least on the early stages with Flashbot, is that they really had, in terms of values, an alignment with Ethereum. So I think there is a room here to take a more decentralized approach, but that is going to come down to the technical specification. So I'm not sure you've read some of the proposals that have been made by Flashbots, but that's where the battle is happening right now, and which sort of standard is going to be adopted is going to sort of impact the answer to your question. And some other initiatives are also existing, like federation of relayers are starting to be created. People looking at what Flashbot is doing and saying, can we do the same thing but in a more decentralized way? So yeah, watch out for that.
Hello, thank you. You had a slide on the inverted pyramid of value.
Yeah.
Isn't there also a scenario where this doesn't pan out? And so I'm just playing devil advocate, right?
Of course.
All the smart contract execution happens on layer 2s. The mainnet is just a settlement layer. And hence, this has an adverse effect on actually the demand for blocks, because it all happened on layer 2s. And layer 2s end up accruing more value than the main chain.
I see what you mean. Yeah, so the way I see it is really that the growth might happen in parallel. So like, sure, currently you can see layer 2s are competitors, or like putting a pressure that is not, that doesn't have a positive impact on the layer 1. But you can also say that if we improve UX and we have so much growth, so much adoption, that first we will need layer 2s just to catch up with that. And so the pressure basically is going to continue to grow, maybe not as fast on layer 2, but still in a steady fashion for layer 1. So what you really want to achieve is growth on both layers, and not so much, it's not that, for example, layer 2 growth is going to take anything away from layer 1 growth, it's going to actually feed it. So I think it's going to be fine. I think maybe a threat that you can have is that some layer 2s are layer 1 agnostic. Yes. So if, depending on which layer 1 they integrate with, you can also have this value that I'm talking about. That's why I put L1 and Ethereum in parentheses, because it can be another layer 1, actually. Yeah. Okay. Sorry. We can talk after if you want. Thank you very much. Have a nice day and happy merge to everyone.